you already know that public class has to be stored in a Java file with the name that matches the name of the class exactly. That's why if you need to rename your class and give it a different name, it's a multi-step process. Such process is typically referred to as refactoring. So the process that requires a specific action but is consistent of multiple steps. So for example, if I want to rename main app to become an invoice app, so I copy it from here, copy this name. What you would normally do is select this. I typically double click, it gets selected in the source editor, right click, and there's a choice to refactor. So refactoring, the first option here is to rename. So it gives me this dialog box. I paste the name of the new class, and you can also rename it in your comments as well. So that's probably pretty standard selection right here. So then you say refactor, and you see that the integrated development environment renamed the class, changed the name of the file in which the class is stored, and also updated this comment right here. So that's pretty convenient, and just be aware of these steps. You cannot just change the name, you have to be consistent in all of this. So declaring variables, let me just clear this up a little bit so that we can practice with declaring variables. So a variable is a placeholder for some sort of value. For instance, I can say integer count equals 0. So this is a declaration that creates a new variable named count. And notice that I have to decide what type of data it should be. A double is a floating point variable, which means it's a real number with a fractional part. So here I would like to say price equals 0.0. Okay, so this is these are examples of variable declarations. So when variables are when you need these variables, they have to be declared first. Then you can start using them. Variable declaration is a statement. That's why you have to have a semicolon at the end of it. It's just a very basic part of syntax. And I prefer that you also provide an initializer for your variable. If, for example, I forgot my initializer, or I forgot that the variable has never been initialized with any value, which means that its memory was allocated, but what is in that memory nobody knows. In that case, if I try to do this, say system out.println, and try to print the value of this counter. Now I go to my code here, to my project, and say clean and build. It gives me an error and suggests that the variable count might not have been initialized. So compiler is pretty consistent at looking at unsafe operations such as this counter. It has never been provided any value, and even this innocent attempt to print the content of this variable is not allowed by the compiler. So you really need to provide some initialization to specify what this variable contains. So you can do this later on. Right here you can say counter equals 100. So then this won't be a problem. But in a situation like this, I think your choice should be to initialize it as soon as you declare a variable. I would also say do not declare your variables too far away from places where you're using them. So a better style would be to declare counter right next to where we begin using it, which is this output statement. Data types present a set of values together with a set of operations. So basically what we're dealing with is that when we're creating an integer, we're expecting it to be able to used in addition, subtraction, division, multiplication, and other arithmetic operations. You can compare it with 0 or compare two integers together, whether the one is greater or less. Right? So all of this is a set of operations or behaviors that come inherently with an integer data type. Likewise, the double is a floating point number, so same thing. You can do arithmetic operations, you can compare double values and so forth. So anyway, so this is why you make a decision what data type you're giving to your variables, because you're anticipating certain behavior or certain operations. And of course it also gives you the range of values and the basic storage for your values in memory. Primitive data types all have keywords designated with them. So for example, double and int, you can see that these types, the types double and int are highlighted, which suggests that they are keywords, and they're called primitive data types or basic data types or fundamental data types. And the reason for such recognition of these data types is that your CPU, your hardware, understands these data types directly. It means that individual CPU instructions can do operations with these types of data in computer memory directly. No additional pre-processing or parsing is required. We mentioned here a Boolean data type, which is I'll show you, Boolean flag equals true. So Boolean variables only have two values, true and false. So we'll see examples of Boolean data types in the future, but I'd suggest that for now you don't really have to use a lot of these variables, but this is one of the primitive data types which is available. In Java programming environment, it's quite predictable what are the sizes of your primitive data type variables. Character is occupying 2 bytes in memory. Remember, byte is a combination of 8 bits in memory, and is a very basic, byte is a very basic type of memory unit. So there is a separate type for a byte, which is keyword byte. It allocates an 8-bit object in memory, but character in Java is 2 bytes. Short is the type of an integer, which is also 2 bytes in size. Integer is 4 bytes in size or 32-bit, and long is 8 bytes. It's a long integer. Double is also occupying 8 bytes in memory. These are integral data types, which means that they don't store fractional numbers like this price right here. So there are 2 floating point data types, which is float and double. The difference between them is the precision with which the fractional numbers can be stored. Double stands for double precision floating point number, and float is for a single precision. So float occupies 4 bytes in memory, and double is occupying 8 bytes in memory. So this is this Boolean data type I mentioned earlier, allows only 2 values, true and false, and these are themselves keywords of Java. So normally you could have a variable that indicates true or false condition of some sort. is calculation complete, is device ready, is file open, and things of that nature. However, be aware that it looks like a good idea to create a Boolean variable to indicate some condition, but in reality a combination of multiple Boolean values creates a difficult code to maintain and understand. Whenever possible, you should probably maybe use some other ways to find out whether conditions are true or false, instead of checking them and storing the results in a Boolean variable. So for now, just you can just forget about this data type and try not to use it in your coding. We'll have more examples of this in the future.